Hi friends, in this session we study about the properties of numbers. So here you see we have to study some basic properties: closure property, commutative property, associative property, distributive property, and then additive identity and additive inverse, finally multiplicative identity and multiplicative inverse. In this session we study about the closure property. So to talk about these properties, we need to think not only about the numbers themselves but the operations what we perform on them. So let's we start with closure property. So look at here, closure property of the operation of any set states that the operation of any two numbers equals another numbers of same set. So here we see about the closure property. This is the set of natural numbers on set of whole numbers and set of integers and set of real numbers with the operation addition, subtraction, multiplication and division. So first we see about the addition with natural number. The closure property of natural number addition states that any two natural numbers equals another natural number. We already know that the natural number what we use for counting are called the natural numbers, and it starts with 1 and all are positive, 1 to infinite, 1 2 3 4 5 and so on. So if we add two natural numbers, see what happens. If we add 1 with 2, so we get 3 here. It is also a natural number. If we add 2 plus 9, which is 11, it is also a natural number. So on natural number addition is closed, so this is okay here. Look at here. Now we see about the whole number. In the whole number, the number set where we include 0 in the set of natural number, so we get the whole number. So it starts with 0. If we add to whole number, we get always whole number. So 0 plus 1 is 1, 0 plus 9 is 9, and 1 plus 3 is 4. These are all whole numbers, so it is also closed here for whole number. Now we see the closure property of integer number addition states that any two integer numbers equals another integer number. We know that the integer number are negative and positive, -3, -2, -1, 0, 1 2 3, both the sides goes to infinite. So if we add -3 with 2, so we get -1, which is an integer. If we add -3 -5, we get -8, it is also an integer. So in this way we see if we add two integers, we always get integers, so it is closed at addition. Now we see the closure property of real numbers addition states that any two real numbers equals another real numbers. So real numbers, there are some rational numbers, some irrational numbers, integers, whole, everything is there. So first I explain you 1 plus 1 over 2. 1 over 2 is a rational number and 1 is an integer or the natural number or the whole number. So we get here 3 over 2, which is a rational number, which is a real number. If I had to add root 5 plus 2, it could be written in this way, 2 plus root 5, so it is also a real number. So if we add two real numbers, we always get a real number. This is all about the addition on different sets. So look at here in this chart, all are closed here in addition. The set of natural numbers, set of whole numbers, set of integers, set of all are closed here. So the closure property applies here in addition everywhere. Now we see about the subtraction. What happens here, we see closure property of natural number subtraction states that any two natural number equals another natural number, whether we see is it correct or not. So we see here, if we subtract two natural number, we subtract 3 minus 2, which is 1, it is natural number, okay. But if we have to subtract 2 minus 3, which is -1 is not a natural number, so it is not closed. So this property is not right. So we can put in this way, it is not closed here. so it is not closed. So look at chart, subtraction of natural number is not closed, it is wrong. So now we see the closure property of whole number subtraction states that any two whole numbers equals another whole number. So the same thing would be here. If we 0 minus 1, it is minus 1, which is not a whole number, so it is not closed here also. And now we see closure property of integer number subtraction states that any two integer numbers equals another integer number. So if we minus 3 minus 2, we see what happens now. So minus 3 plus 2, which is minus 1, this is integer. So if we subtract two integers, we always get an integer, so it is closed for integers. And for real number it is also closed. If we subtract two real numbers, minus root 3 plus minus root 3 minus 5, so we could write in this way, minus 5 minus root 3, it is a real number. So in this way the closure property closed here for subtraction of real numbers. So look at in this chart, you see for subtraction natural number is not closed, whole number is not closed, but the integers and real numbers are closed here. Now we see about the multiplication. Closure property of natural number multiplication states that any two natural numbers equals another natural number. If you multiply two natural numbers, as we multiply here 1 into 2, which is 2, and 2 into 3, which is 6, these are all natural numbers, so it is closed for multiplication. And here you see, if closure property of whole number multiplication states that any two whole numbers equals another whole number. If we multiply two whole number, we get always whole number. If we multiply 0 with 3, we get 0. 0 is a whole number. If we multiply 2 into 3, we will get 6 here. It is also whole number, so it is also closed here. Now we study closure property of integer multiplication states that any two integers equals another integers. So 2 integers minus 3 into 2 is also integer minus, so it is minus 6, which is an integer. So in this way we get the integer if we multiply two integers, so it is also closed here. Now the last one we see the closure property of real numbers multiplication states that any two real numbers equals another real number. We have to multiply 2 into root 3. Root 3 is an irrational number and we have to multiply with the 2, so we get here 2 root 3, so which is a real number. So in this way we could get the real number if we multiply two real numbers. So look at in this chart, we see that the multiplication are always closed for any sort of numbers, natural, whole, integers and reals. Now we see about the division. Now we study about the division, the closure property on different sides. For division we see whether it is closed or not. The closure property of natural number division states that any two natural numbers equals another natural numbers. We see what happens now here. If we divide 2 by 3, so we get a rational number which is not a natural number, so it is not applied here. Now you see for whole number, if we divide any whole number with another whole number, we get infinite here. You see here at the integers also, if we minus 1 divided by 0, so it is infinite, so it is not defined. We are always getting here for root 5 over 0 is also infinite, so these are not closed on any side. So look at here on the division for the closure property, it is not closed in any set, as the set of natural number, whole number, integers and real, it is not closed anywhere. So here we have studied that what is closure property. Thank you.